4, 5, 6,
This call is now being recorded.
7.
This call is now taking notes.
So let's say we have a matrix like this. You see, these parts, these horizontal parts here, these parts here, you call them the rows of a matrix. These parts, they are the rows of the matrix. So you call these ones, you call them rows. Then for the columns, you also have matrices have rows and columns. Then columns are identified by the vertical arrows. So the vertical arrows identifies the columns here. The vertical arrows identify the columns either downward or upward. Let's see upward. Yeah. So these ones are the columns. This tells you the number of columns you have. So try to illustrate this, that this tells you that these are rows, while this one tells you that these are columns. So in a matrix, like we've said, these horizontal lines, the horizontal lines here as illustrated in the picture, the horizontal lines tells you the number of rows, while the vertical lines tells you, when you're reading vertically, it tells you the number of columns. That's the illustration. The vertical arrows shows you the number of rows, while the vertical arrows tells you the number of columns. So in ordering this matrix, that's trying to know the name of this matrix, there are two rows here. This matrix has two rows and three columns. You see the rows, that there are two rows, two horizontal arrows. If you have to count horizontally, you see that you have twice. So you have two rows. Then for the columns, if you're counting vertically, you will see that we have, let's count the columns here. You see that we have one column vertically, 1, 2, and then 3. So there are 3 columns. And if you are to count the rows, you see that horizontally 1, 2. So there are 2 rows and 3 columns. The order of this matrix is read as row by column. You have to state the number of rows by the number of columns. So the order of this matrix would be, the order of this matrix would be 2 rows by 3 columns. So this matrix is a 2 by 3 matrix because you have 2 rows. As illustrated there, the horizontal arrow tells you the number of rows. Then the vertical arrows, the one that are read vertically, tells you the number of columns. So you can see the illustration. Horizontally, we have 2 rows. And vertically, when we count vertically, we have 3 columns. So the order of this matrix is a 2 by 3 columns. Please take note. The matrices, the order of matrices are read row by column. Row by column. You have to state the number of rows first before you state the number of column. So 2 rows by 3 columns. Do you understand? Do you understand? Okay. So now we'll proceed to identifying the names of each of these We'll proceed by identifying the names of each of these matrices. Okay, so we'll proceed by trying to identify the names of each of these matrices. Let's see how we can do that. So let's take this matrix, for instance. Let's say A, B, C, D. So what would be the order of this matrix? The order of this matrix, if we count the rows, we have two rows. If we count the rows, there are two rows here. So we'll say two rows by, we count the number of columns. You see that there are two columns as well. So two rows, two columns. So this is a 2 by 2 matrix. This is a 2 by 2 matrix because we have two rows and two columns. Let's look at other ones. What if we had something like minus 3 and 5 here? What would be the name of this matrix? Here, if we are to count the rows, remember you always count the rows first. You count the rows first and illustrate that as row by column. So here, if we are to count the rows, remember the rows are counted horizontally. The horizontal part, that gives you the number of rows. So if we are to count horizontally, you see that we can have two rows here. This is it. We count, you see, 1, 2. So there are two rows. We'll say 2 by 2 rows horizontally. That's the counting. Then 2 by, now we have to count the number of columns. Now we have to count the number of columns. The number of columns are counted vertically. Columns are counted vertically. So if we count vertically, we'll have just once. We count just once. There's just one column. So this matrix would now be a 2 by 1 matrix. So this matrix will now be called a 2 by 1 matrix. Reason being that we have two rows and one column. Please do not forget that you always count the rows first before counting the column, and the rows are counted horizontally. You count the rows horizontally. Come back here, you see the illustration. The rows are counted. The horizontal arrows tells you the number of rows, while the vertical arrows tells you the number of columns. See the illustration here at this circled part. The horizontal arrow tells you the number of rows, while the vertical arrows tells you the number of columns. So we shall proceed to name other matrices. Let's look at other matrices and see how we can determine their order of matrix. So let's say we have 0, 1, 2, 3, 4, and 5, 6, 7, 8, 9 as it is here. So what would be the order of this matrix? Who wants to try? Who wants to try to determine the order of this matrix?
No, it will be a 2 by 5 matrix.
Hello, who will identify? Who will help identify all of these?
2 times 5 matrix.
Sorry, come again.
2 times 5 matrix.
Two. Okay, you don't say it is a 2 times 5 matrix. You say it is a 2 by 5 matrix. By, not times. But yeah, I
Okay.
get your point. That's a good try. I get your point though. This is a 2 by 5 matrix. Here is a 2 by 5 matrix. This is a 2 by 5 matrix because if we are to count the number of rows, remember the rows are counted horizontally. So if we are to count the number of rows, we count 1, 2. So we'll have 2 rows. So 2, and remember we always have to say the row first. So we have 2 rows. Then if we proceed to count the number of columns, we'll have 1, 2, 3, 4, 5. So there are 2 rows and 5 columns. So this tells us that this is a 2 by 5 matrix. Then let's look at one last one, and then we'll proceed to the elements of a matrix. So let's identify this matrix: 2, 3, 4. I think this is okay. 2, 3, 4. The order of this matrix. What name should we give to this matrix? So let someone else answer apart from this young man who just answered the last one. Someone else. What would be the order of this matrix 2, 3, 4? Remember, count the number of rows, that's horizontally, by the number of columns vertically. So who else wants to tell us the order of this matrix? Who wants to try? All right, remember that we're counting the rows before the columns. The rows are counted horizontally. We had the rows counted here. 2, for the first one, we had 2 by 2 matrix. The second one, when we count the rows, we had 2 rows by 1 column. So say it was a 2 by 1 column. This third one, the young man helped us just now, counted the number of rows, counted 2 rows, and then 5 columns. So this say it's a 2 by 5 matrix. Then here we now have the last one. We have to count the rows. We count the rows horizontally, 1. We have just 1 row here. So this is a 1 by. Now count the number of columns. That's we're counting vertically now. 1, 2, 3. So we're counting 3 columns. This is now a 1 by 3 matrix. So this is a 1 by 3 matrix here for this one. So now we shall proceed to getting the elements of a matrix. Elements of a matrix, that is how to identify the position each element occupies in a matrix. How to identify the position that each element occupies in a matrix. So looking at elements of matrices here. Now, if we have a matrix, let's say 1, 0, 4, 2, 5, 7. Let's say we have this matrix here, and you're told to find the position of, let's say, 1, for instance, the element 1, the position of the element 1. Let's call this matrix A. Let's give the matrix a name and say matrix A. Now, if you are asked something like, what is A 21, for instance, you're now told what is A21, because the matrix A, that's the capital letter A, is the name of this matrix. While the small letters, like this small letter now, the elements in matrix A, they are all denoted by small letter A. If this is a matrix P, the elements in matrix P will be denoted by small letters P. If this is a matrix Q, the elements in matrix Q will be denoted by small letters Q. That is why here in this question we have matrix A, and we have those elements there, 1, 0, 4, 2, 5, 7. Now, what is A21? You see it's in small letter because they're asking for the position, the element that is in A21. This A21 means the element in the second row and the first column. So here we have to identify what A21 means first. The A21, that's A base 21, is the element in row 2, column 1. The element in row 2, column 1, that's what they're asking you for. What is A21? They're asking you to determine what element is in row 2 but column 1. So let's see what element is in row 2 and column 1. For identify row 2, this is our row 2 here. Row 2, that's the second row, the one I just striped out now. That is row 2. Column 1, column 1 meaning the first column. So this 2 here, see column 1. So count this, you see the column 1 there, now our first column. So you see that the element in row A21 is 2. What is A21? A21 is 2. That is the element in row 2 and the first column. Remember, this matrix has 3 columns. This matrix here now has 3 columns. I think we should pick it up from there first. This matrix has 3 columns and has 2 rows here. There are 2 rows. You can see the first one, row 1, row 2. Then column 1, see column 1, column 2, column 3 as well. Now, if you're asked to find A21, it simply means that you have to go to, remember, rows before column. So A21 means the element in row 2, column 1. So if we look for that, we'll have row 2. This is row 2. Column 1, meaning the first column. That point of intersection, the element at that point where row 2 intersected column 1, that element there is the element A21. So our A21 is, to identify that, our A21 is the element 2. That's A21. Now let's proceed. Let's say what if we're asked here, let's say let's find A23, for instance, or let's say A22. Let's say A22. What is A22? That's A base 22. So what you're being asked to look for here is the elements in row 2, column 2. The element in row 2, column 2. So let's try to see. Let's see. The element in row 2, column 2. You trace that. You have row 2. This is row 2. Column 2. This is column 2, the second one. So you see the results we have there is 5. The element in row 2, column 2 is 5. You see it here. I'll go again. I'll go again here. Row 2, column 2. Row 2. This is row 2. Column 2. Column 2. That element, that intersection, the element at the point of intersection where row 2 met with column 2. That element there is the element that denotes A22. So you can see the value we have there is 5. So A22 is equal to 5. So this is basically what to do. So let's try one where you guys will have to determine the elements yourself. Let's say Q. Let's say we have a matrix Q. Then we have um, 0, 2, -4, 0, 2. So we have 0, 2, -4, 3, -1, 5, 6, 7. And then we are now being asked to, let's find Q, or identify. I think that's a better word to use. Let's say identify Q3, Q13. Identify Q13. So you're being asked to identify the elements in the first row and the third column. Identify Q13. Remember, this matrix is a 2 by 4 matrix. There are two rows, as you can see horizontally. The horizontal ones are the rows, while the vertical ones are the columns. So here, this matrix is a 2 by 4 matrix. Now you're being asked to find Q13 because the name of the matrix is matrix Q. Now find Q13. Q13 is the element in row 1, column 3. So who can tell us the element in Q13?
-4.
-4. Very good. The element in Q13 would be -4. This is because we have row 1. Always remember, you have to read the rows before the columns. Always read the rows before the column. So this is because Q13, that's row 1. Column 3, you can see the point of intersection where the row and the column met. It's -4, just like um, the young man just answered. So Q13 would be -4. That is the value. So Q13 equals to -4. All right, so someone else should help us identify. Let's continue with, let's say, identify Q24. Someone else,
7.
what would be the value here? 7. Good, 7, because Q24, that's the row 2, the element at row 2 and column 4. So if we follow this, we'll have row 2. This is the second row, row 2, column 4, 1, 2, 3, 4. Row 2, column 4. That point of intersection where the row and the column met is called the element at Q24, which is the element at row 2, column 4. And then we have 7 here as the result. So Q24 is equals to 7. So this is how you order matrices. This is how you order matrices. So remember, for those that didn't join early enough, we started by introducing the topic matrices, and we talked about what a matrix is. That a matrix is the arrangement of elements in rectangular blocks. Then we just gave 2 random examples of matrices. Then we proceeded to how to order matrices, how to give a name to each matrix. We said that you have to count the number of rows by the number of columns. Then the rows are counted horizontally as illustrated here. The rows are counted horizontally, while the columns are counted vertically. And when we are ordering matrices, we have to say the number of rows first by the number of columns. So the number of rows, you see it here, row by column. So do not forget, row by column, and the rows are the horizontal ones, while the columns are the vertical ones when you count. Then we named that matrix. We said it is a 2 by 3 matrix. This matrix here. Now we proceeded to order these other matrices. We have A, B, C, D here. We counted the rows, counted the columns, and we identified it as a 2 by 2 matrix. Proceeded to this other one, -3 and 5. We counted the rows. There were 2 rows, but just 1 column. Then we named this a 2 by 1 matrix. Proceeded to this one, we counted the number of rows as 2. There are 2 rows, and then the columns were 5. So a young man helped us to identify that, which is very correct. Then the next, these 2, 3, 4, we counted just 1 row. But the columns, vertical counting gave us 3 columns. So we called this a 1 by 3 matrix. Then we proceeded to the elements of the matrix, how to identify the elements of each of these matrices. We said A21 is the element at the second row and the first column. Second row, first column, that gave us 2 as A21. Then we proceeded to A22, the element at the A22 here, the element at the second row and second column. That gave us 5. Second row, second column. Then we had another matrix here, matrix Q. We identified Q13, and then Q13, we identified it to be the element at the first row, row 1, and then column 3. Row 1, column 3 gave us -4. Someone helped us with that. Then we proceeded to Q24. Q24, that's the element at the second row and the fourth column. So the second row, the fourth column, that gave us 7 points of intersection. See there where the row and columns met. 7. So now we're proceeding to the um, scalar multiplication of matrices. So see it here, scalar multiplication. So looking at scalar multiplication of matrices, how to multiply a matrix by a scalar. How you multiply a matrix by a scalar. Let us say that we have matrix M, for instance. Matrix M is the matrix 7, 3 minus 3, 2, let's say 8, and then 0. So let's say we have this matrix M to be this. Then you were told to find maybe 2m. We have matrix M here as these matrices here. Then you're told to find 2m. What is the value for 2m? So this 2 here is the scalar. It simply means you are using this scalar. The 2 is the scalar. You're using the scalar to multiply the matrix. Now by doing this, you arrange your new matrix like this. So 2m would be 2 plus 7, 3 minus 3, 2, 8, 0. Like this. So to find 2m, this is the matrix, the original matrix. The first row we have 7, 3 minus 3. The second row we have 2, 8, 0. Now find 2m. 2m would be you using the scalar 2. That's scalar multiplication. 2 is the scalar. You'll be using the scalar 2 to multiply this matrix. That's why I wrote it this way. 2, then the matrix. So what this does is that the scalar 2 multiplies each element in the matrix. The scalar 2 multiplies each element in the matrix. And then you have the new matrix 2m becomes 14. 2 multiplies 7. 2 multiplies 3, have 6. 2 multiplies minus 3, have minus 6. 2 multiplies 2, have 4. 2 multiplies 8, 16. 2 multiplies 0, have 0. So this is the scalar multiplication for when 2m, the scalar multiplication 2m. Simply you just using the scalar 2 to multiply each term in the matrix. You're multiplying each term with the matrix by the scalar 2. So let's look at another example. Let's call this example 2. Let's call this example 2. So let's say that we have let's say that we have the matrix P, for instance. Let's say we have matrix P to be equal to 8, 20, 4, and 17. Okay, so let's say we have this P, matrix P to be equal to 8, 20, then you have 4, 7 for the second row. Now find 1/3 of P. Find 1/3 of P. So find the matrix 1/3 of P. So again, you're still using the scalar 1/3. 1/3 here now, 1/3 there is the scalar. So you still have to use the scalar to multiply the matrix P. You use the scalar to multiply the matrix P. Then this becomes 1/3 of P will be 1/3 multiplying the matrix 8, 20, or 17. See there, 1/3 of P. You have to multiply that matrix. When you do that, you would have a new matrix, 1/3 of P, to be equal to, when 1/3 multiplies 8, there you have 8/3. 1/3 multiplies 20, have 20/3. 1/3 multiplies 4, you have 4 over you have 4/3. Then 1/3 multiplies 17, you have 17/3. So this is new matrix. So this is your new matrix here. This is your new matrix. Do you understand? Do you understand? Listen, so do you understand? Hello, I need you to respond. Do you understand?
Yes, sir.
Sorry, say that again. Do you understand?
Yes,
Yes,
sir.
sir.
Okay, okay. All right. So this is what you do when you're using a scalar to multiply a matrix. This is just what you do. Now we'll proceed to addition of matrices. We'll proceed to addition of matrices. So we'll proceed to addition of matrices. Okay. Addition of matrices. All right. So if we have two, if we have two matrices, please excuse me for a moment. Excuse me for a moment. All right. So can you see the board? Hello, can you see the board?
Yes, sir.
Yes, sir.
Okay. All right. Sorry, I muted the call. I forgot. All right. So we're now looking at addition of matrices. We're looking at addition of matrices here. Addition of matrices. So we'll see. Let's say that we have two matrices. Let's say matrix C to be equals to 2, 5, 6, 0, 1, 3. And then we have another matrix. Let's call this matrix K. Let's call this matrix K and say matrix K is 4, 0, 7, 2, 6, and 8. Then, if you're told to find the sum of these two matrices, if you're told to find the sum of these two matrices, so let's say C, find C plus K. Find C plus K. What do we do? It means that you'd have to use every element in matrix C. You'd have to use every element in matrix C to add to each element in matrix K as well. Every element, every element in matrix C is being added to every element in matrix K. But then, can you just add them just like that? No, you would have to add elements that are in the same positions. elements that are in the same positions, you add them together, and then when you're done with that, you have a new matrix. So here we will start by arranging the matrices and try to add them together. So say 2, 5, 6, 0, 1, 3. Then plus, for the other matrix you have 4. The other matrix you have 4, 0, 7, 2, 6, 8. So you see the two matrices here now, C plus K. Now each element in the same position in each of the matrices add up to themselves to get a new matrix. So here 2 and 4 add up, 5 and 0 add up, 6 and 7 adds up, the elements in same position. The same thing for the other ones. So now you should have something like this. 2 plus 4 gives 2 plus 4 gives 6. 5 plus 0 gives 5. 6 plus 7 gives 13. Then we also have other ones at the bottom. 0 plus 2 at the bottom. Same positions, remember, same positions. 0 plus 2 gives 2. 1 plus 6 gives 7. Then 3 plus 8 gives 11. So your new matrix for C plus K, your new matrix for C plus K would then become this matrix here. C plus K is equal to the new matrix you have here. 6, 5, 13 for the first row, and then 2, 7, 11 for the second row. Now take note, two or more matrices can only add up or be subtracted from each other if they have or if they possess the same number of elements. The same number of elements, and not just the same number of elements, if the two matrices are of the same order. So for instance, a 2 by 3 matrix cannot add up to a 2 by 2 matrix. Look at what I'm trying to say. Let's try to look at this now. Let's try to look at this. Let's say we have this matrix 5, 6, 7, 8. And then you're being told to add it to another matrix 3, 4, for instance. So this is impossible because the first matrix is a 2 by 2 matrix. See here, this first matrix is 2 by 2, but this second matrix is 2 by 1. So you can't add them up, because if you say 5 plus the 5 in the first matrix, say that 5 plus 3 at the second matrix, you have 8. What then do you add 6 to? The other element, 6. What then do you add it to? So you see that the two matrices are not of the same order. So in a case like this, it is impossible for you to add this. You say impossible because the matrices are not of the same order. So you cannot add them together. So that's basically how you add matrices. Just add matrices that are in the same positions together, the same positions. Remember when we talked about elements of a matrix, those matrices are in the same element, the same positions. You add them together, then you have the new matrix. When matrices are not of the same order, just like this one here, it is impossible for you to add or subtract them. All right, so I'll drop on now so that you attempt this addition and see what the new matrix would be. Then we proceed to subtraction of matrices. So if we have matrix M, it will be equal to 1 minus 1, 3, then minus 6, 7, 4. Then we'll have matrix N to be equal to, let's say, 5, minus 4 and 2. Okay, while this is minus 7 minus 4 and 3. So let's see, find find m plus n. All right, so I would need someone to help us with this one. We have these two matrices m. We have these two matrices. We have m and matrix n. Now, what is m plus n? So let someone do this. In short, the whole of you, you can get this done, and let's see what our new matrix would be. We'll compare the results to other people's results in the class. Then we'll come to a conclusion if it's correctly done. All right, so get to work. Anyone who is done can just simply let us know what results you came up with. 30 minutes. Has anyone gotten an answer yet? Anyone with an answer yet?
Yes, sir.
So what's the result?
6 minus 5 TV minus 13 TV 7
Okay, for the first rule, 6 minus 5.
TV.
Can you come again? 3.
No, 5
Okay, so 6 minus
plus
5
5
and 5. Then for the second row, minus
minus
13,
13
3, and
TV 7.
7. All
Yes.
right. So let's hear from another person first. So we've gotten one answer from these are the young lady here. So let's hear from another person. The guys, don't fall our handle. A girl has gotten one answer. Don't fall our handle, guys.
Second row.
Come again.
Second minus 13.
No, start from the first rule. Start from the first rule. Tell me the elements you got.
6 minus 5 and 5.
Your first rule, what was the first element there?
6 minus 5 and 5.
All right, what about the second rule?
Minus 13 minus 11 and 7.
Minus 13, minus 11, and 7. Would you want to look at that's your minus 11 again? Do you want to review that? Minus 6, minus 11. Review your minus 11 again.
Mm.
Do you still feel that's correct? Or you've gotten hold of a mistake there?
Let me check.
You made a mistake, right?
Yes.
All right, so what was that supposed to be? That minus 11, that element there, what was it supposed to be?
11.
11? That's still
Yes.
not correct. It's still not correct. Remember, you're adding 7 plus minus 4. 7 plus minus 4. All right, look at this. Look at this. Look at the board. 7 plus minus 4. What's the result when plus multiplies minus?
minus
7 plus minus 4. So thank you, when plus multiplies minus, you have minus. So that's actually 7 minus 4. And the result is 3. Do you understand? This
Yes.
person who made the
Yes.
mistake just now, do you understand?
Yes.
All right, so that's 7 minus 4 actually. And the result there should be 3. The result there should be 3. Okay, that being said, we can now say that matrix, because two persons already has gotten the same answer, and I think I agree with that. So our matrix m plus n should actually be 6 minus 5 and 5 minus 13, 3 and 7. So this is the new matrix we'll have when we do that m plus n. So this is basically how you add matrices together. Now we'll quickly look at the subtraction of matrices, how we subtract matrices. So subtraction, let's look at subtraction. So our aim here is to determine how to subtract two or more matrices. Our aim here is to determine how to subtract two or more matrices together. So let's say we have matrix A to be 3. So that's matrix A, and matrix B to be equal to, let's say, minus 6 minus 1, 2, and 7. So have matrix A to be the matrix we have there, 35 for the first row, and then 4 minus 2 for the second row. Then for the other matrix B, have minus 6 minus 1 for the first one, the first row, then 2, 7 for the second row. So let us see the value for A plus B. Let us see the value for A plus B. Sorry, we're subtracting. So let's say find A minus B, and let's see the result you have. So for A minus B, when you're doing this, remember you have to deal with elements that are in the same position. So for A minus B, you're starting with the elements in A first. So the element in A, that is 3 minus 3 and minus 6, they are in the same positions there in the two matrices. So you have to deal with 3 and minus 6. So now you're actually doing this 3 minus 6. This is what you're doing for that first one, 3 and minus 6. A minus
minus
B.
9, 6, 2 minus 9.
Sorry, come again.
Minus 9, 2 minus 9.
Okay, so I would let's hold on. Well, I'm doing this myself. When it gets to your turn, we'll see whether what you just said is correct. So let's be done with this one first. So we're actually saying 3 minus 6. That's why you have those two minuses there. I put one in the bracket. And for the other one, we have 5 dealing with minus 1. So we have 5 minus 1. Remember that it is A minus B. You see there that it is A minus B. That's why we're starting with the elements in A first. Say 3 minus 6. That's why it's in the bracket. Then for 5, we said 5 minus 1. See? Then we go to the second row. There we have 4 minus 2 for the second row. Then for the other one, we have minus 2, minus 7. We're starting that again. For the first one, we have 3 minus 6. 3 minus 6. Then Then we proceeded to say 5 minus 1. Then subsequently, we did say 4 minus 2, that's for the second row. Then lastly, we said minus 2 minus 7. So let's see the results that this gives. For A minus B, we have the matrix 3 minus, that changes into plus. Does everybody understand that? The minus changes into plus. Okay, so there we have 9. Then if we proceed, 5 minus 1, that gives 6. Then at the bottom, 4 minus 2, that gives 2. Then minus 2 minus 7, that gives minus 9. So this is the matrix you have for A minus B. So this result she got, the other person that was trying to give an answer the other time, he started with the minus 9. Or did I misunderstand you? Do you understand this?
Yes, sir.
No, I'm actually talking. Someone gave an answer earlier, and the person started with a -9. So I'm actually talking to that person. Please respond.
I'm the one. I made a mistake.
Okay, have you seen the error now?
Yes, sir.
All right. Now I need you to do something. This is A minus B. There's a difference between A minus B and B minus A. There's a difference. When we did this, when we said A minus B, we started by from the elements in A minus the elements in B. But if you were told in this same matrix, if you were told to find B minus A, this same matrix, find B minus A, they are not the same. A minus B differs from B minus A because in A minus B, you're dealing with the elements in A first, and then you proceed to deal with the elements in B. But for B minus A, you would have to deal with the elements in B first, then before you proceed to dealing with the elements in A. Do you understand?
Yes, sir.
Why aren't the others responding? Do you understand? I do not need, hey, this young lady, please keep quiet. You've been the one responding all the time. I need others. Do you all understand?
Yes,
Yes,
sir.
yes, sir.
All right. So why were you leaving the work for the young lady? And or you're practicing ladies first. No ladies first here. Everybody's first. So ask a question when you're not clear, and please respond in the class. Okay.
Yes,
All
sir.
right, so we are proceeding to see the difference between A minus B and B minus A. So for A minus B, we dealt with the A first before applying the B. But now we'll have to look at B minus A. For B minus A, we would have to deal with the B first before the A. So you see this arrangement, you would have to deal with B first. So instead of you saying 3 minus minus 6, you will have to say minus 6 minus 3. Instead of you saying 3 minus minus 6, you will have to start with the B first. Then you say minus 6 minus 3. That is B minus A. So for B minus A, so for B minus A, we'll have for B minus A, we'll start with the B first. So here we have minus 6 minus 3. So you start with B first instead of A. Minus 6 minus 3. Then you proceed to the other one. Minus 1 minus 5. Then at the bottom, again, B minus A. So again, you start with the B first. So 2 minus 4, 2 minus 4. Then you proceed to the last one. Proceed to the last one. 7 minus minus 2. 7 minus minus 2. That is 7 minus minus 2. There. Now the result should be a different matrix from A minus B. So you see B minus A now becomes the first row you have minus 9 minus 6, 2 minus 4 you have minus 2, then 7 minus 2, that would be 7 plus 2, that gives 9. So you have 9. So if you try to juxtapose between the two of them, the both of them, when you juxtapose between the both, it's as if you're actually multiplying through by minus. When you juxtapose a minus b and b minus a, you see it looks like you're multiplying through. For b minus a, it looks like you're multiplying by minus 1 actually. So that's what you do. A minus b differs from b minus a. For a minus b, you start with a and then subtract the elements in b from it. But for b minus a, you start with b, then subtract the element of a from it. All right, so this classwork. Let's take this classwork and then see how far you understand this. So let's say, all right, let's do this classwork. Let's say we have, let's say we have p be equal to p to be equals to minus 2 minus 1 minus 5 3 0 8. And then we have q to be equal to 4 minus 7 and 2, then 3 again minus 1 and minus 2. So let's say we have this matrix P and matrix Q. So I need you now to find P minus Q. Let's say find P minus Q and Q minus P. Alright, so let's deal with this. Find P minus Q and Q minus P. So this is the classwork. So everyone get to work. By the time you're done, I think the class will be almost over. Let's add more to it so that it can just, let's add more to it. Let's say number 3. Find 2Q minus P. Then number 4, find 2P, find P minus 2, find P minus 2P. Alright, so let's do this. Find 1 P minus Q, 2 Q minus P, 3 2Q minus P, 4 P minus 2P. So you already know what to do. For number 3, you have to find the scalar multiplication of Q first. So you have that 2Q, you have to find that scalar multiplication. Then that new matrix minus P. Then for number 4, P minus 2P, you have to find the scalar multiplication there as well, 2P. Then you say P minus 2P. All right, so let's deal with this. When you are done, you let me know. and then we will when you're done, you let me know, and then see what to do and end the class. If the time doesn't permit, we'll talk about it in the next class before we proceed. So when you finish, just draw my attention, let me know. Is anyone encountering any difficulty? Is there any difficulty?
No, sir.
All right. Please, you just pick the question so I can mark the attendance while we're at it. I have to disconnect the board so that I can mark your attendance quickly. Oh, yes, I need to.
So I'm done.
All right, okay. So we'll just keep the results. Just keep the results. Then we'll talk about it. We'll see how it is from the next time we have our next class. Is that okay? Is that okay? We'll talk about the result the next time we have a class on Thursday. Is that okay?
Yes, sir.
All right. So until next time, do take care of yourself. Bye for now. You guys did well today.